Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 283, move zeros. We're given an integer array nums and we need to move all the zeros to the end of it while maintaining the relative order of the non-zero elements. And we have to do this in place without making a copy of the array. So this makes the question slightly more complicated. So here's an example. We've got 0, 1, 0, 3, 12, and the relative order of all the non-zero elements is 1, 3, and 12, with the two zeros at positions of index I and positions index 0 and 2 are both at the end of the list. And in the second example, we've just got 0, so we just return 0, and we're also given some constraints. So the way we can do this is by using a two-point solution, and this pattern is quite common with Leetcode, but it's having one pointer at the beginning of our list and going through our list, and whenever we find a non-zero element, we replace the element 1 at the value for the we set the value at the index of our left pointer in this case to 1, and then we move on to the next number. Well, is 0 not equal to 0? No, it's not. 0 is 0. So we go on to 3. Is 3 not equal to 0? Yeah, yes it is. So we go back to the left pointer and we set the value at the left pointer index to 3, and then we shift the left pointer 1 to the right again, and we keep doing this until we get all the non-zero elements in the same order at the beginning of the list and the 0 elements at the end of the list. So let's code this up in Python. Let's create our left pointer. We'll set it equal to 0, and then we'll say our right pointer, instead of using a while loop, let's just use a for loop. So let's iterate through our nums list, and let's say if the number at our right pointer is not equal to 0, or we find a non-zero element, we can say nums L will be equal to nums R. So we put the number at our right pointer at the number at our left pointer, and we increment our left pointer by 1. We don't need to increment our right pointer because our for loop does this for us. But we need to wait on for a second, because once this for loop has finished, our left pointer may still not be at the end of our list. So we need to say, while our left pointer is not at the end of, is less than the length of our nums list, we can carry on incrementing our left pointer. And remember, we need to have 0 elements at the end. So the elements after this for loop finishes will just need to be 0 elements. So we'll just set nums L equal to 0. And we don't need to return anything because we're just modifying nums in place. So let's run the code. And now let's submit our code. And we pass all the test cases. And of course, we have a quite efficient solution as well. So in terms of time complexity, well, although we've got 2 loops, this is the first section and this is the section, but altogether, it's just a single pass over our list. So the time complexity will be O of n time complexity, and space complexity, it will be, although we are setting some pointers, it will still be constant time, so O of 1 space complexity. So I hope this video made sense, guys, and I'll catch you in the next one.